Hello, everyone. Today we're tackling a really interesting question, one that might seem simple, but has a super important answer. Do acids actually need water to show that they are, well, acidic? Let's find out.
So, you've probably learned in school that acids turn blue litmus paper red, right? But is that the whole story? What if there's no water around? Does the acid still work? Cello, let's check this with a simple little experiment.
All right, to get our answer, we're diving straight into an activity. This is going to show us the secret ingredient that acids need to reveal their true nature. Let's see how it's done.
Okay, so the setup is pretty easy. First, we take some solid sodium chloride, that's just our regular table salt, and put it in a completely dry test tube. Then, very carefully, we add some concentrated sulfuric acid. And you'll see that right away a gas starts coming out of this tube. But what gas is it?
That gas is hydrogen chloride, or HCl gas. See, when sodium chloride and sulfuric acid react, they produce sodium sulfate and this HCl gas. Now, we know HCl is the formula for hydrochloric acid, but right now it's just a dry gas. Let's see what this gas can do.
And now for the main event. This is where we're going to find our answer. We're going to test this HCl gas with two different pieces of blue litmus paper. It's a tale of two papers. One is dry and the other one is wet.
So here's the most important test. In case 1, we bring a dry blue litmus paper near the gas. And for case 2, we use a moist or a slightly wet blue litmus paper. The only difference here is that little bit of water. What do you think's going to happen?
And look at this, our first result. With the dry litmus paper, absolutely nothing happens. Kuch bhi nahi. The paper just stays blue. So this dry HCl gas has zero effect on it. This is a big clue, right? Without water, we are not seeing any acidic reaction.
But now for case 2. The second that moist litmus paper comes near the HCl gas, bam! It turns red immediately. This is the classic acid test we all know and love. So the same gas that did nothing a second ago is now acting like a proper acid. Why? What changed?
It is time for the big reveal. This experiment clearly shows that water has a secret but super important role to play. Let's break down what's actually happening at the molecular level.
The conclusion is crystal clear. Dry HCl gas by itself is not acidic. It's only when HCl is in an aqueous solution, which is just a fancy way of saying it's dissolved in water, that it shows its acidic properties. So water is the key.
So why is water so special? What magic is it doing? Well, it allows the HCl molecule to do something it just can't do on its own, break apart, or as we say in chemistry, dissociate into ions. This process, ion formation, is the real reason for acidity.
Think of it this way. When HCl is a dry gas, it's made of complete, whole molecules of HCl. These molecules are neutral. They don't have the power to change the litmus paper's color. They need something to come and break them apart.
And that something is water. You see, when water is present, a special ion is formed, and this ion is the real hero of our story. Let's meet the hydronium ion.
So look, when an HCl molecule meets a water molecule, it immediately splits. The hydrogen from the HCl leaves the chlorine and latches onto the water molecule. This creates two new things: the super important hydronium ion, H3O+, and a chloride ion, Cl-.
This hydronium ion, H3O+, is the actual thing that causes acidity. It's the presence of these hydronium ions that makes the litmus paper turn red. The takeaway is simple. No hydronium ions, no acidic properties. Simple as that.
Now you might be thinking, hey, why not just say H+ ions? Isn't that simpler? Well, the thing is, these tiny hydrogen ions, or H+, are super reactive. They can't exist all by themselves, so they immediately grab onto the nearest water molecule to become the more stable hydronium ion. That's why we always write H3O+ in our equations.
Okay, so this whole water is the key idea, does it only apply to acids? Not at all. The exact same logic is true for bases too. You see, bases also need to break apart in water to show their properties. For example, take sodium hydroxide, NaOH. When you dissolve it in water, it splits into sodium ions and hydroxide ions, or OH- ions. And it's these OH- ions that make a solution basic.
And here's a very important definition for your exams. Lots of things are bases, but not all of them can dissolve in water.
The ones that can dissolve in water, like the sodium hydroxide we just saw, get a special name. They're called alkalis.
All right, we've understood the science part. Now let's talk about how to use this knowledge to get full marks in your exams. This is your practical guide.
If you remember just one thing from this whole explainer, please make it this sentence. Acids show their acidic properties only in the presence of water. This is your golden line. It's the core of your answer for any question on this topic.
Now let's quickly go over what not to do. A very common mistake is saying that dry HCl gas is acidic. Nope, it's not. Another mistake is just forgetting to explain why water is needed. And finally, always remember to write the hydronium ion H3O+, and not just H+.
So how do you write that perfect answer? It's simple. First, always use the correct term, aqueous solution. Second, clearly explain that water is needed for the acid to dissociate into ions. And third, you must mention the star of our show, the hydronium ion, and its formula, H3O+. So, let's end with this easy-to-remember chain. No water means no ions, and no ions means no acid. It's that simple. Water unlocks the power of the acid. Remember this, and you will ace this concept in your exams. Thanks for joining me.